All right, this video will walk through how to name ionic compounds. You want to be able to write the name of the compound given the formula and write the formula of the compound given the name. And we didn't get the chance to get through this in class. And since I'm gone on Friday, I wanted to make you a short video for the rest of your note guide. You'll find additional practice problems and practice videos posted on your nomenclature resource, posted on Google Classroom. So ionic naming, these rules are mainly for binary compounds. Those are compounds that have only two elements, and since we're ionic, this is going to be a metal and a nonmetal. Our rules of naming are just two of them here, with a couple exceptions. Name your first element. Your first element will always be the metal. We always write the metal first in ionic compound. And we use exact name as it appears on the periodic table. So you look at your periodic table to find this name. And then the second part of it is looking at your nonmetal, that's your second element, and you take your nonmetal just as it appears on the periodic table and change the ending of the nonmetal to an "ide." So if you want one example here, oxygen, that will appear in a lot of our ionic compounds, will turn into oxide. We change the ending to "ide." We drop that last little bit off. There's only a couple nonmetals on your periodic table, so you'll see all of these endings, and you'll get familiar with what goes in front here for each of those elements that are nonmetals. These exceptions, you can read through that yourself. We'll come back to that when we run into them in the examples here. So our first example, this guy is our metal and then our nonmetal, and we're going to use our rules here. Name the metal first, so that's calcium, exactly as it appears on the periodic table. By the way, you do not need to capitalize the names of chemical compounds. They can be lowercase unless they're at the beginning of a sentence. So that's our first element, calcium. Our second element is sulfur. And instead of sulfur, we're going to stop and, we're going to change the ending to "ide." My L goes right there. Let me fix that. This is sulfide. You'll see sulfide spelled with a PH in the middle too. That's an old way to spell it, and that's okay as well. Our next one, same thing. We name our first element potassium, just as it appears on the periodic table. And we name our second element, it's the same amount we had above. So now this is potassium sulfide. Our next one, we name our first element aluminum, just as it appears on the periodic table. And now we have something strange here. It's not attached to only one other element. And if we go back up here, our rules were primarily for binary compounds, two elements, a metal and a nonmetal. And if we look back down here, we do have our metal, that's aluminum, and now we have two nonmetals attached to it. So this must be one of our exceptions here. And it's this exception right here. This is a polyatomic ion. Poly meaning many atomed ion. And these ones, we don't change the ending to an "ide, but we do need to find what is that polyatomic ion and what is the name of it. So you need to go to your little table here. You've got a table of polyatomic ions. It was given to you in class on Thursday. And on this table, you'll find groups of nonmetals that work together to have a charge. And the one that we care about is right here, PO4. The one phosphorus and the four oxygens collectively work together to steal 3 electrons from our metal. Now the name of this phosphate, that's what we care about for naming our compound. We are not going to change the ending of any of these when we see them in ionic compounds. We're just going to take that name and we're going to write it right into our name of our ionic compound. It'll be aluminum phosphate. Our next example also has a polyatomic ion attached to potassium. So we're going to start with our same beginning of our name, potassium. Don't change the name of the metal at all off the periodic table. We recognize there's not just a single nonmetal attached here, but there's two. So this must be a polyatomic ion. I go back to my chart. I'm looking for SO4. And SO4 is right here. And the SO4 collectively, those 4 oxygens and that 1 sulfur, steal 2 electrons from the metal, and the name is sulfate. Don't change the ending. We just keep it sulfate. So this is potassium sulfate. Okay, our next one is again we have sulfate here, but attached to a new metal. We're going to neglect changing the end because we have a polyatomic ion, and this will be iron sulfate. But now we have something new here. This particular example has this little dot here. It'll actually appear as like a multiplication symbol, just like that. And it has 7 H2Os. These are compounds called hydrates. And a hydrate is a compound that can attract a water molecule, usually from the air. It's exposed to the air. And H2O in the air, when it bumps into a sample of iron sulfate, maybe you've got it on a petri dish or something, and it's going to bump into it, and the iron sulfate will attract the H2O and make it part of its structure. It doesn't bond to it in the same way that we make an ionic compound. It's just attracted to it like a positive would be to a negative, maybe just like an electron attracting a positive part of an atom. Okay, so we go up here to our exceptions, and at the bottom right here, hydrated compounds use Greek prefixes. You will find that list of Greek prefixes right in your note guide. And we want to find the Greek prefix for 7. If you look on that little column, you will find the Greek prefix for 7, is hepta. And then because it's a hydrate, we're going to say heptahydrate. So it's the same rules for naming the beginning, and then we're going to say how many H2Os are attached. Hepta is 7 hydrate. Our last one here is cobalt, CO. You'll find that on your periodic table. Spell it just like it is on your periodic table. Cobalt. And now we have a single element again. This is iodine, and iodine needs the ending changed to "ide" because it's a single atom off of our periodic table. Cobalt iodide. Now the cobalt iodide and the iron sulfate, we're going to do one more thing with. Let's go back up here. And the only exception we haven't used yet is the multiple charges of ions. They need to have a Roman numeral. The Roman numeral is the charge of the metal. Only metals will have multiple charges. So you're looking for that first element in your formula. Let's go back down here. Iron and cobalt both appear in the D block. D block elements, nearly all of them, can have more than one charge. These ones up here, we have calcium, potassium, aluminum, potassium again. Those elements are in columns on the periodic table called the main group elements. That's our S block and our P block. And they always make the same charge when they make an ionic compound. The exception to that are some of the elements like lead right underneath your metalloids. Okay? Lead can actually be a +2 or +4. Whoops, +4. So let's go back to these guys. Iron and cobalt are in the D block. They can have more than one charge. So in my name for this, I'm going to make a little bit of room here. Oh, I can't split it apart. We need to add a Roman numeral here. It's going to squeeze right between the iron and the sulfate. And we have to figure out the charge of the iron. Here's how you figure out the charge of the iron. This compound is neutral. It has one metal ion, Fe, and it has one polyatomic ion, SO4. On our chart, that SO4 has a charge of -2. It steals 2 electrons. It must have stolen both of those electrons from the single iron atom. And so the iron atom, losing 2 electrons, becomes a +2. And so this is going to be iron 2 sulfate. The cobalt will also get a Roman numeral in between the two. And we go to our periodic table, we find cobalt, and you'll see it's in the D block. It doesn't follow any rules for charge. It can actually have multiple charges. And so we're going to do the same thing. We have one cobalt, and we have 3 iodines. Each of those iodines steals 1 electron. They have 7 valence electrons, and they need 8. And so getting 1 extra electron for each of those will steal a total of 3 electrons from the cobalt, and this becomes a +3 charge. You can always do the math at the end. +3 minus 1 minus 1 minus 1 gives neutral, 0. They need to add up to 0. And so the cobalt is a +3 charge, and this would be cobalt 3 iodide. That's how you do your naming. You've got some example problems in your note guide. please go into your Noteguide and do those example problems. I will post the solutions to those example problems when I post the notes on Google Classroom. I'll also make a little video walking through these one by one if you want to walk through them with me. Thanks.